Okay, let's look at something called neutralization reactions. A base will react with an acid, or an acid will react with a base. And when you do that in the lab, with a burette and a conical flask, etc., we call that a neutralization, or we call that a titration. So we talk about titrating an acid or titrating a base. And that's very commonly done to find out the concentration of an acid or a base that we don't know by making them react, titrating them with a base or an acid, depending what it is, of a concentration that we do know. Typically, we need to add an indicator, a solution that will change color when the neutralization condition has been achieved, when you have the same number of moles of acid that you have of base. And we call that the equivalence point. And the equivalence point is the point in which you have as much acid as you have base. And typically, because you tend to mix compounds that are both colorless solutions and the resulting mixture is also colorless, and you don't know, use an indicator, a substance that will change color when that equivalence point has been reached. So when you are at the equivalence point, that means that the number of moles you have of acid is the same as the number of moles you have of base. And that's how you can work out the concentration of an unknown. Because if you, for example, don't know the molarity of the acid, but you know the molarity of the base, and you know how much base you have added, and you know how much acid you started with in your flask, then you can work out the concentration of the acid. So you use the two things. You use first the knowledge that in the equivalence point, once the titration has finished, the number of moles of acid is the same as the number of moles of base. And you also use the knowledge that molarity, concentration, is the number of moles of a substance divided by the volume in liters. And if you substitute your number of moles of acids, and instead of numbers of moles of acid, you write the molarity of the acid times the volume of the acid that you have put in the flask, and you time it at the stoichiometric coefficient of the base, because sometimes the reactions will be 1-to-1. You need 1 mole of acid to react with 1 mole of base. But sometimes the reactions do not work so neatly 1-to-1. You will need 2 moles of acids to react with 1 mole of base, or 3 moles of base to react with 2 moles of base of acid. The coefficients will not be simply as many moles of this one. You will need moles of the other one. You will need 2 moles of acid per mole of base, or 3 moles of acids per 2 moles of base. The stoichiometric coefficients do not work so well. So you do need to put the stoichiometric coefficient of the other. So the molarity of the acid times the volume of the acid, and you multiply it by the stoichiometric coefficient of the base. And this gives you how many moles of acid you have used. And then the molarity of the base and the volume of the base, and multiply by the stoichiometric coefficient of the acid, which is how many moles, 1-to-1, 2-to-1, 3-to-2, 2-to-1, you need to react with all that acid. And this is how many moles of base you have used. And typically, there is one thing you don't know. Maybe you don't know the molarity of the acid, but you know you added 25 milliliters in the flask, and you know the molarity of the base that you have chosen, and you know how many milliliters of base you have added in the burette. Or it might be the other way around. It might be that what you don't know is the molarity of the base, but you will know information about the acid. And in all those things, the molarity of one of them is the only thing that you don't know. And that is how you can calculate the molarity of an unknown acid or an unknown base by titrating it with either a base or an acid, depending on what you don't know, that you do know the molarity, and by using an appropriate indicator, one that will change color in the moment in which the number of moles of acids equal the numbers of moles of base. So let's have a go at a hopefully quite straightforward reaction. Neutralizing sodium hydroxide with hydrochloric acid. You generate sodium chloride and water. You've got 35.62 milliliters of sodium hydroxide. You don't know the concentration of sodium hydroxide, but you have used 25 milliliters of hydrochloric acid of that particular concentration. What is the concentration of the sodium hydroxide solution? Stop the video now, please. Okay, so again, I need the moles of base in the equivalence point are the same as the moles of acid. I know that the moles of base will be the molarity of the base, which is NaOH, times the volume of the NaOH that I have used. And the moles of acid will be the molarity of the acid, in this case HCl, times the volume of the acid. And the coefficient of the acid times the coefficient of the base. And in this case, it doesn't matter because the reaction lovely is 1-to-1, so those two numbers will be 1. What is the molarity of the sodium hydroxide? Well, I do not know, because that's the question, where the question is asking me. I know how much I have used. It's telling me, the problem is telling me that I used 35.62 milliliters. And you can keep it as milliliters because you're going to have another volume also as milliliters. So those milliliters will cancel out, or you can transform them to liters because molarity is moles per liter. I'm going to keep it at milliliters. If that confuses you, convert the milliliters to liters, both the 35 and the 25. I'm going to keep it as milliliters. Okay, the molarity of the hydrochloric acid, 0.0998. The volume of hydrochloric acid, 25 per 2. Sorry. So, if I arrange this equation, 0.0998, 25.2 divided by 35.62, and assuming I haven't got my numbers wrong, this is a molarity of 7.010 to the minus 2. So 0.007 moles per liter, sorry.